your little microphone. Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you've joined us. Our topic today is CI/CD best practices for your DevOps journey. We've got a great panel today. I'm excited to introduce our folks. Before we do that, today's webinar is sponsored by CloudBees. My name is Mitch Ashely. I'm going to serve as your host and moderator and also chime in a bit on the panel as well. A few housekeeping items to take care of. We are recording the webinar, and we will send an email with a link to the recording as well as the slides. It'll also be available on DevOps.com. We also have an ebook that's in the works that will follow in a few days after the webinar. So we will send a separate email with a link to that ebook on this topic. So we definitely encourage you to ask us questions. All the panelists love to interact with the audience, love questions. So please enter those into the GoToWebinar panel, questions panel. Now let's move on to our topic, CI/CD best practices for your DevOps journey. It's my great pleasure, my distinct pleasure, to introduce the following gentlemen that are on our panel today. First is Brian Dawson. He is DevOps evangelist with CloudBees. Doug Tidwell, technical marketing director, CloudBees, and myself with DevOps.com. Would you say just briefly, Brian, Doug, introduce yourselves in that order?
Oh, absolutely. And I think it's important so people can tell us apart that we speak up. So I'm a DevOps evangelist and a director in our product marketing organization at CloudBees. I've spent, I kind of hate the number, over the past 25 years in software development with a primary focus on optimizing at various levels, from the technical stack up to the process that we use to deliver software. And I'm excited to be here with you, Mitchell, after seeing you at DOES in Vegas.
That was great.
Sharing some of our lessons with the attendees here.
Great. Doug?
Hello, everyone. I am Doug Tidwell. Again, we wanted to introduce ourselves so you could tell Brian and myself apart. I have been, I will not admit, unlike Brian, I will not admit how many years I have been in software. It's greater than 25, I'll leave it at that. And the last thing, just as a personal plea for me, as you can see, I am locked in a closet. I have been in here since February, so hopefully with a good evaluation today, they'll let me out. So thank you in advance for your consideration.
Hopefully we'll get some good feedback, questions and comments. But by the way, 25 years, who's counting amongst friends? So, okay, great. Let's get started, dive into our content. Brian, I think you're kicking things off. If you want to take it away, that'd be great.
Yeah, so just to give a quick overview of what we'll cover today on today's webinar. Well, first, I want to call out that we decided to hold this webinar because we realized that there's a lot of discussion about the future of software development and delivery, yet there's a realization, as we'll cover later, that there's a lot of people that are still implementing some of the foundations of software development and delivery. So we figured that it was a good chance to review some key practices. So we'll cover kind of what's beyond DevOps with something called the Software Delivery Management Strategy. And then we'll review a summary of 10 CI/CD best practices. But since we can't give justice to all 10 in the length of this webinar, we'll pick 6 key practices that we'll double click on. We'd like to keep this interactive. There's a lot of knowledge on this panel, so we'll break for discussion. And then we'll reserve some time at the end of the webinar for questions and answers. Now, for some of you, as we go through this, I'll set the stage. This may seem rudimentary. Our goal is not to explain to you to the nth detail how to implement DevOps, but rather to just help shore you up on CI/CD. So for those that have been practicing CI/CD, take this as an opportunity to review some of your practices as a refresher, then go back and double check what you're doing today. For those that have tried but failed, look at some of these practices and some of the discussion points as potential reasons for why you might have had trouble and inspiration to try again. And for those that are just starting, consider these practices kind of underpinnings or tenets that you should try to follow as you get started with CI/CD. And so with that, I'd like to start off by reviewing what we call the DORA metrics, the DORA Fantastic Four. So Doug, if you could take us to the next slide. So if you've been attending any conference, if you've been on DevOps.com, you are probably well aware of the DevOps research and assessment metrics, the Accelerate State of DevOps report. What we have on the screen here is from learnings or lessons, metrics from that report focused on DevOps elite performers. And what we're finding is that people that practice DevOps based on solid continuous integration and continuous delivery practices are seeing fantastic improvements. They can deploy code 46 times more frequently. Their lead time from commit to deploy is an astounding 2,550 times faster. They are 1/7 less likely to fail or to have changes fail. And if they do, which will happen, they can recover 2,406 times faster. They're outstanding and impressive numbers that our elite performers are seeing, and targets that we should all strive for. But I'd like to call out that even as we identify these practices, not only has not everybody achieved these numbers yet while we strive them, even for our elite performers, we're finding that things aren't perfect. Next slide, please. And when I say things aren't perfect, I base this on a number of factors. To get the full detail and coverage, please go back and revisit our recent webinar on software delivery management, where we really drill in. But what we found talking to developers, engineering management, and operations is that they still suffer significant pains and frustrations to get software out the door. And we're finding out from the business that oftentimes, even when we get that software out the door faster, we haven't necessarily ensured that we've delivered the right thing and delivered value. And what we found is that within our software organization and beyond, we still have disconnected and fragmented teams, tools, and processes. Even as we connect across the silos of dev, QA, and operations and automate through those, we haven't necessarily connected across our teams, and we haven't connected to other stakeholders in the software development process. So we function with disparate data, no common language, and disconnected processes. If we can move to the next slide, please. So, what we're realizing and we have to acknowledge is it takes a village to truly deliver software, or more important, it takes a village to truly deliver value. If we take this graph in account, in the middle, we get a picture of what software development and delivery is today if we exclude the orange bar. And what we find is that we have a bunch of stakeholders that influence the software development and delivery process, but they're disconnected, right? Executive staff, the C-suite, and finance operate on their own cadence with their own objectives. The design team, the same. We throw stuff over the wall after developing it for marketing to digest what we've delivered, for docs to create documentation and embark on training, and then sales to figure out how to drive revenue. And then we have to support and service that. What I like to call out is, the old adage, if a tree falls in the forest and no one is there to hear it, does it make a sound? And we can apply it here, right? If I deploy software, I develop and deploy software, but it doesn't get to market, get used by users, and ultimately improve the business, have I truly delivered software? And I make the case no. So what we need to be moving towards is getting these functions connected, operating on shared intelligence and insight to drive business impact at velocity. I think oftentimes we're just focused on driving and measuring velocity.
Brian, if I can just interject on this, what do you think it is that we haven't expanded DevOps far enough beyond the development operations, the IT organizations, into really knowing what the business value, what the impact is? Because ultimately that's what the business is asking us for, right?
Right. Well, and I think there's a range of issues. I'll hit a couple of them, right? I think one is there's an inability or sometimes a lack of energy and effort to overcome impedance. And even as we look to implement CI and CD and DevOps, what I had found in my experience is, say, oftentimes we practice water, scrum, fall because it was easier for that dev team to implement a new process within their silo. I often hear about QA saying, guys are implementing, teams are implementing continuous delivery, but we haven't been involved. Again, there's cross-functional impedance within the software organization, but then when you scale out, there's significantly more impedance influenced by organizational structure, cultural norms, incentives, right? Now, beyond that, I will say that there's been a history of, treating IT as that group of guys like the sitcom IT, group of guys and gals, unfortunately, mostly guys, sitting in a basement in ties in a dark room pounding away at the keyboard. And so the business has kind of grown up as the software development organization being somebody that we submit requests to a black box, and then we sit there and tap our fingers and wait for something to pop out the other side, right? So we need to overcome all of that and then some to get everybody functioning together so we can continuously improve and innovate. And I'll talk a bit on the next slide about what we and others believe the answer to that is. And that's, shoring up your CI/CD and DevOps, but then looking above and beyond it to implement a software delivery management or SDM strategy. And the way we look to overcome some of this impedance and cultural mismatch and preconceived notions of IT and app dev is to recognize that part of the separation is people have a bunch of data stored in different tools across the organization. We need to look to reference or establish a system of reference for common data, tie that data together. That then establishes us to have shared and universal insights. So no longer is it a matter of manual handoffs, meetings to reconcile different perceptions, misunderstandings, but rather we are all looking at the same thing. This then gives us an opportunity to build a common connected process, and that sets the stage for a culture where all functions are collaborating, and we're achieving what I'd like to call not just continuous delivery or continuous deployment, but continuous everything, where the organization is involved and moving at the same pace of commit to deploy. Now, what we're realizing is if we want to get here, and if we can advance to the next slide, that we actually have to build the foundation first, right? And what that means is, like those DORA elite performers, we have to work to shore up and improve at our continuous integration and continuous delivery and DevOps practices, right? We still have to address our competency in the area of technical concerns between the traditional plan, code, deploy, and release before we can build up to the area that software delivery management addresses, where we can focus more on driving value and impact, which will act out strategy and influence revenue. So what we want to do is up-level the software development function so that it's closing the bridge between technical concerns and business concerns. And at this point, it is where we get software development and IT out of the basement. The business embraces it as a core function and harnesses software development and delivery competency to create two differentiators for the business. And what I look at it as is get beyond the software development lifecycle, or SDLC, get beyond the value chain, and let's begin to look at the full software value lifecycle. Now, unfortunately, as we learned at DevOps World, Jenkins World last year, if we can go to the next slide, please, as we learned at DevOps World, Jenkins World last year, the reality is far fewer organizations are truly practicing CI/CD than is widely reported. oftentimes we get caught up in a bubble and we forget about developers that are still dealing with legacy systems, teams that are really just getting by and keeping the lights on. They're struggling against organizational challenges, or even people that misunderstood or misimplemented these practices. So an anecdote to share is at DevOps World, Jenkins World last year in San Francisco, Jez Humble was our keynote speaker. And of course, he wrote the seminal book on continuous delivery, as well as, or included in that on continuous integration. And he surveyed the audience. He said, how many people are practicing continuous integration? I think practically everybody raised their hand, said, keep your hand up. And then one by one, he went through some key practices, some of which we'll share here. And he said, if you're not doing this, lower your hand. By the time we were done, barely anybody in the audience had their hand up. So similar to the stats here and stats we're seeing in other reports, we had a number of people claiming to practice CI/CD, but finding when we really broke it down, they skipped some key tenets. So we're going to take an opportunity to review those. Now, if we can go to the next slide, I'll give a quick run through those 10 practices. Excuse me, I forgot that this was here. So, the takeaway here and the premise of this webinar and session we have is that the industry is moving forward. Software is being embraced and will be better embraced by the business via software delivery management. But to get there, we need to get good at CI and CD and DevOps. So it's more important than ever that we shore up those practices and ensure our teams, our organizations, and our business are best positioned for the future.
Brian, if I can interject, why do you think it is, and I think most people recognize CI/CD as the place to start on your journey to DevOps. Why is that the place to start? Why is that such a fundamental element of what we're doing?
Well, I'll first look back to kind of errors we've seen in the past, right? So if you look at, if people have been in this business for a while, we had, PPM solutions, which were all the rage. We had application lifecycle management, or ALM solutions, which were all the rage. What I oftentimes found is those solutions were manually populated sort of dashboard systems that tried to connect data without being tied into the execution layer, right? So that means that to really achieve software delivery management, we have to have automated and cross-functional systems at the execution level to plug the systems into, to truly unify data, unify process and information. And really, I think just like CI/CD and DevOps, software delivery management is about flow. It's about extending flow, established at the technical level in the software function, higher up to incorporate the other stakeholders in the process. So if we haven't established flow at lower levels, we can't build up to establish it at higher levels.
Great, thank you very much.
So now I want to call out disclaimer before I go into this and then shortly hand it off to Doug. CI/CD kind of built on agile tenets and DevOps is not dogmatic. It's not prescriptive. The reality is every organization, while they have a lot of commonalities, has slightly different challenges. And you need to figure out the practices that work best for your organization. But in general, there's a few key principles and tenets that you should consider when implementing CI and CD. And we'll cover these here. I won't go through them one by one now. I just want to call out that the ones in bold are the key practices we'll hit today. And again, you'll get a detailed list of all 10 of these practices and a follow-up ebook after this webinar. So Doug, are you ready to take over now and I'll have a drink of water?
I shall do my best. So thank you, Brian. So let's go through our best practices, the highlights of them at any rate. The first one, not controversial, is that you should track your work items, and that covers everything that's user stories, that's requests for enhancements, bug reports. Also, you should keep in mind definitions of your infrastructure and environments. This is really crucial for CI and CD as you move forward to DevOps and eventually SDM. I do want to stress this should be a tool accessible to everyone, something like Jira, which I'm sure many of you are using. This should not be an Excel spreadsheet. This should not be Post-it notes stuck to the side of your monitor. This needs to be something electronic and accessible to everyone across your organization. So moving right along, uncontroversial best practice number 2 is to use source code management. So with this, obviously, you want to track all the changes made for your release. There are a couple of types of source code management systems. A decentralized system, such as Git, that is the most common, certainly for modern software projects. Git holds the dominant market share. But if you're working with legacy code, you may deal with more centralized systems such as Subversion, CVS, RCS, etc. You need to keep that in mind as you're looking at your project. If you're going to work with legacy systems, you need to consider how to integrate a centralized version control system, or you may want to consider moving that legacy system to a decentralized system.
Hey, Doug, I'd like to jump in real
Another
quick.
important.
Oh, I'm sorry,
Please.
just to jump in real quick and call out, and Mitchell, I think you brought this up earlier in our discussion. If you can shift everybody to new tooling more apt for DevOps, great. But if you can't, then even as you're implementing kind of your ideal process in a test case or on a small team, to get your organization aligned around software DevOps and software delivery management at a later stage, you need to be designing and choosing flexible tooling and systems so you can include both those modern systems Doug called out and those legacy systems.
Yes, it is a great time to consider. Maybe it's time to move to Git, at least for maybe new projects, or gradually bring things on. Great time to examine the tools and potentially shift while you're implementing this stage.
Yeah, awesome.
Okay. All right, another aspect of source code management is as people are writing code, they will at some point commit that code. And it is vitally important in a continuous integration environment to commit frequently. So however we have things set up, if we're not committing frequently, we're not going to be successful. If I'm a developer and I wait 3 weeks before I commit a bunch of code, or I branch off and work on that branch for 3 weeks, then try to merge it, I've really broken the principles here. When I commit lots of code at once, if the build breaks, it can be very difficult to determine what exactly has gone wrong. That could be multiple components. It could even worse be that all of the features were implemented correctly, but not in a compatible way. So then I have to take a step back, start re-examining all the code that has been written, and try to figure out how to fix the problem. As with any aspect of software development, we've known this for decades, if you commit a small amount of code, it's easy to fix that problem. The sooner in the cycle you fix the problem, the cheaper and faster it is to fix it. So moving right along, the next thing you need to consider in your source code management system is how triggers work. So what exactly makes a build happen? The ideal, and Brian will talk about this more in a few minutes, is to trigger on every commit. So if someone commits new code, we trigger a build. You can also trigger when a developer makes a commit to their branch. You can trigger when a developer makes a pull request, and you'd certainly want to trigger when you merge those PRs into the main branch. So again, trigger on every commit is the ideal. Try to get as close to that as possible. And it's also not a bad idea to have a scheduled build as a backup. So you may want to set a backup or a build trigger that says every night at midnight, we'll launch another build just to see how things are going.
So Doug, it looks like Mitchell, did you have a comment?
Yeah, I was just going to ask, You used to say commit at the end of the day. If you haven't committed anything, commit at the end of the day. Yeah, but I think we're talking about committing more frequently, right? As we get kind of units of work done. To your point of, because that can kick off the build, the integration, the testing, find problems earlier. Is there a good rule of thumb that you've seen experience to say this is a good time every time you've finished implementing a functional piece of code, or was a good metric? Right. Is there such a metric?
You nailed it for me, and Doug, you could chime in. I think it's when you've committed a function, when you've completed a functionable, reasonable, testable piece of code. It doesn't need to be the full functionality of the feature, right? But maybe I've completed the function that serializes input over a web request out to the internal file system. That may not be the complete functionality that we're looking to deliver, but let me go ahead and commit that piece. Let the integration test kick off. Now, of course, one practice we haven't explicitly called out here is do tests locally before you commit. If you're in and again, this may vary certain situations. One thing to bring up here is we've seen advents like with Jenkins X, where developers can have a preview environment. Developers creating cloud native apps can issue a pull request and then have a preview environment automatically created to go through the continuous integration of their code, stand up an environment, and allow them to play with it. That has shifted some of the local development to the cloud. But the main takeaway of that is commit after you've implemented some functional unit and after you've validated it in an isolated environment.
Right, and I would also say, Brian, again, I think you're going to talk more about this in a few minutes, but if your work items, your requirements, your bug reports, etc., if those are written at the right level of granularity, then I'm not going to be able to work on that for very long before I need to do a commit.
Yes, and that's big. It's difficult. Oh, sorry, Mitchell, go ahead.
No, I was just going to add that, with microservices, even nanoservices, API economy approaches to software design, that lends itself to much smaller units of code, much smaller functions. So it's a lot easier to commit that. Here's a new API call. Here's a new service update to a microservice, et cetera. So it's actually easier and the more you get into a DevOps style, cloud native kind of architecture.
Yeah, and I think just to quickly lean in on that, we didn't get in here. It's kind of beyond the scope of this. We'll get into some in the ebook, but there's a lot of things that influence our ability to kind of right-size work and move at velocity through the chain. Architecture, refactoring to microservices, decomposition of the application, team structure, right? Aligning kind of team structure to be cross-functional and work more completely together. And then to Doug's point, how we describe our work, right? We can't create a huge requirements document with big monolithic individual requirements, hand it to a developer, and then say, you know what, give me a testable build in a week. It's not going to happen. So great point, Mitchell.
Not if you want to keep your developers, you won't. Right. Side point. Sorry, Doug, back to you.
No worries, thanks. So best practice number 3, again, related to your source code management system, is the notion of tags instead of branches. Again, this is an ideal. You may not be able to achieve this based on your tools and how they work, but the idea is you want to commit and or merge, if you have pull requests, to the trunk frequently. Ideally, you always commit to the trunk or the master branch, whatever your tool calls it. So the longer, as a developer, the longer I create a branch and work on that branch, the more likely it is that changes have been introduced elsewhere that are incompatible with what I'm testing locally in my branch. So as long as I'm doing that, we don't have that single source of truth. We don't have that single code base, and this can make maintenance and just simply merging everything much more difficult. So using tags instead of branches is ideal. As we just talked about, we want to implement functions incrementally in small pieces of code with frequent commits. And finally, we're seeing more and more people use feature flags. Feature flags obviously have been around for many, many years, but we're seeing new tools and techniques that allow me to commit code in which the new functions are turned off. And then if you have a management tool like CloudBees Rollout, for example, you can use a management tool to turn those feature flags on and off from outside the committed code. Once it's built, that can allow you to be much more flexible as well. It enables canary deployments, A/B testing, and so forth.
Well, and I'd like to share here,
So,
imagine.
Brian,
oh, sorry. Yeah, I'll just share feature flags because they get me excited. You guys know I rambled on those when we were prepping, right? Seems like a very simple concept, but first, as you called out, Doug, there's a lot of powerful things you can do to tie back to kind of improving incrementally and realize, you know what, there's some work that has dependencies on other teams, other components of the architecture, some work that will take a long time to implement, but we're telling people to commit frequently, right, and constantly test. Well, feature flags can enable us to do this, right? We can flag out the functionality, say that we're implementing maybe in our layer that has a dependency on another layer. When that other dependent functionality is delivered, then we can unflag and we can have something that can be fully tested as a system. Meanwhile, we're able to do code scans, code quality checks, even initiate unit tests. So when it does come time to fully integrate the system and release the flags, we're still not delaying the test, right? We're incrementally sure it works. So anyway, sorry to always jump in on you, Doug. I get excited about this stuff.
Well, I'm going to piggyback on that too.
Those are great points. Let's keep it going, Mitchell.
Yeah, no, I was just going to point out too that your product teams will love feature flags because it gives them flexibility configurations. Let's go after a different target market, get different user persona, whatever it might be. And boy, it sure makes our lives a lot easier. If I could, I want to throw in a question from one of our participants here, listeners. And it's about the trigger build process. Do you assume that we trigger all branches, we trigger and build all branches, or do you subdivide that into subcomponents as far as what gets built when? How does that work?
So I'll jump in and take this. And first, I'm gonna sandbag a bit by saying this can be a complex answer, right? Based on a number of things: your current branching and merging model, your STM type, etc. So, but first, as Doug said, it's recommended that you minimize branching. And there's another question we'll get to, I think, at the end that speaks to that. But if you have long running branches, then it is recommended that you establish the CI process on those branches. So as you work against them, they're continuously being validated. So you have more of a likelihood that when you merge back down to trunk or you merge with other branches, that nothing breaks. You can look at things like the Jenkins multi-branch plugin, which will allow you to set up standard sort of build processes, CI processes that will apply on any branch within a given org within GitHub. I can go on and on about it, but long story short is yes. If anything is working off of mainline and it's living for anything longer than days or weeks at most, then there should be CI processes or automated builds on those branches.
Great, appreciate you answering that question. Yeah, I also wanted to point out too that this idea of size of work, you want to make your checkouts as small as possible, right? Because the fewer things you check out, the less conflicts you're going to have in merging, code changes, debugging things, just makes it a lot easier. So, gone are the days of, let me check out this whole branch of 3/4 of our application because I'm going to work on it this weekend. Don't do those things. It creates a lot more work.
I'll share. Could be one of the worst purveyors that say, hey, I don't know what I'll need.
Right.
Let's just check out the whole thing.
For my 6-hour plane ride or my 18-hour plane ride to Australia.
Yes.
Right. Yeah, what we do now, of course, is we do that download from the air using Wi-Fi. You've done Wi-Fi wrong on the plane if you start a download and the captain turns on the seatbelt sign. So anyway.
You're landing, put your tray up. Oh, I got my code.
Right. All right, let's move along. Brian, I will turn it back over to you as we talk about automating builds.
Awesome. If you can go ahead and take us forward. Now, again, people will say, okay, we're talking about continuous integration. If you know anything about it, automate builds. But you would be surprised at the number of people I've asked if they're practicing continuous integration. They say yes. We schedule our build nightly. And, I think while ultimately, it's debatable whether that's acceptable. It's absolutely not the ideal. Again, based on this principle, integrate and test early and often to find and fix problems fast. If you can integrate every hour or integrate at every change, isn't that better than once a day, right? The other thing is ensure that you've centralized your build, right? Automating build doesn't just mean automate it locally. It doesn't mean have 4 different Jenkins pipelines that run builds potentially slightly differently, which I've seen, i.e., a Jenkins build for development, and then instead of promoting the binary, which we'll talk about build once, promote binary, they promote the source code, and the app deployment team and operations rebuilt the app with a completely different Jenkins job. That's a recipe for error, for disaster. So centralize your build. Automate your build and automate the entire process, i.e. don't have something there in your core CI loop that requires manual intervention. Compile your source code, package the compiled code, compile and package container images. Look at Jenkins Docker pipeline plugin, for instance, and then run this process for every commit. So with every change, you've built your code, and as we'll expand on in a minute, you're now positioned to validate it, as completely as practical. If we can go to the next slide, Doug. Now, there's a key thing here when we talk about validation that is often missed. And I know this can be hard, but still today I go talk to customers that build a CI loop. And again, this is not a CD loop. CI is continuously integrating and validating each change to ensure that it hasn't broken anything early and often. But I often talk to customers that, our build takes 3 hours. Okay, that's great. That may be the case to do an entire build. But if that's the case, then that's not your CI build. Your CI build should take no more than 5 to 10 minutes. Commits should be blocked during the build. Otherwise, we're introducing additional noise and error. What we want to do is block commits during the build and have that an event and encourage a stop the line culture where when the build breaks, everybody stops development and they work together to fix the broken build. Or like some people do, you pass them the duck or the lava lamp, and there's somebody, you have a process for identifying who owns fixing the broken build, but you fix it immediately. If builds are long, what happens without fail is developers divert commits because they don't want to wait an hour, right? They want to continue working. So what ends up happening is changes stack up. Now you have a bulk of changes. You have more chances for error. And there's a lot more we can go into here, but fundamentally, what you want to look to do in your CI loop, obviously, is build. As we said, compile the code, package the code, ensure a successful build. Do an additional level of validation, code scans for code quality checks, code vulnerabilities, code smells are common using solutions like SonarQube. Run unit tests. And any other tests that you can fit in. If you can do functional tests, honestly, I know people that in their CI loop deploy run Selenium tests to check UI functionality. But the key thing is fit it in 5 to 10 minutes. If you can't do that, promote the build to another parallel extended CI/CD loop, and then free up another extended loop, and then free up your core CI loop to allow activity to resume again, right? You want to keep that train moving. When it breaks, stop the line, fix it, and get moving again.
Brian, if I can jump in, one of the teams I was on, they created the energy drink goal that the build shouldn't take any longer than it took to get up and go grab another energy drink. Of course, that time frame got shorter and shorter as the day went on, and more caffeine. But anyway,
but
actually, it was
shot up.
It did. It was a good goal. The other thing I wanted to point out too is that shorter window is going to come in handy when you're fixing production issues or you respond to a security incident or whatever it might be. You know, if you're waiting 30 minutes to build the whole thing or 2 hours or something to build the whole thing to get a fix into production, you know, add that to your debug, triage, fix time. So make that short, as short as you can.
Yeah, like I say, a lot of you may be familiar with emergency change request process. Build your software delivery pipeline such that your regular process moves at the speed of an emergency change request process. All right, so you can be agile and respond. Thanks for that input. To best practice number 6, validate and test. We touched a bit upon this, but to dig in a little bit more, Doug, take us to the next slide. Again, one of the things that amazed me, and this isn't to call out or criticize anybody, implementing these things, especially within mature organizations and teams, are tough. But what I often find is, do you practice CI? Yes, I do. What sort of validation or test do you do on your build? None. Do you practice CD? Yes, I do. But all of our tests are manual. We don't even involve QA. Well, if you don't validate every build, you're just simply not practicing continuous integration. What you're doing is you have automated builds, right? But you're not continuously ensuring integration works unless you're validating it. If you're not continuously testing, if you don't have some level of automated testing, you're not practicing continuous delivery. You're not ensuring that your software is releasable with every change introduced because you haven't validated it works. So, you know, a few key things around this is manage your tests like code or as code. Really, you know, look at practices such as behavior-driven development, test-driven development, to embed the idea of test and validation and automated test and validation in the front end. Now, you may still do manual tests. Most organizations do. In fact, it's usually required. You're not going to have fully automated continuous testing overnight, but you need to understand that this is a key principle in pursuit. Fail the build if your validation fails in CI, as we covered, but moreover, if you go down the line and you're doing functional tests and it breaks, treat it like the CI loop. Stop it and fix it. The further downstream it goes, the more expensive it is. And during this, as we're deploying to run these tests to pre-prod environments, we need to ensure that we have an almost duplicate of the production environment or as close to possible. There's some things that are difficult, like ensuring we have a full data set, though that's getting easier. Feature flags actually allow you to test in production with a real data set. And of course, the advent of containers significantly help with this, because what we can do is we can define the operating environment at dev and have every stage work within a contained container production environment. It'll be the same thing that's deployed.
Hey, Brian, on this topic, can you also talk about, it's a question actually from Benair, how you treat infrastructure as code as part of this entire validate, test, build process? What role does that play in creating the environments when that's controlled or managed by software?
Well, again, and this is the kind of, well, I always like to say everybody thinks they're a snowflake, but they're not. The sandbagging is everybody is a bit different, but the short principle is infrastructure as code should be treated the same as application code. You should apply software development and delivery best practices to that code. It should be checked into a repository. It should be part of your build. You should set up the target environment using your infrastructure as code before you deploy into it. You really want to look at everything that it takes to deliver the service that your application provides to a user, and everything that may affect its performance should be baked into your software delivery development pipeline, your continuous delivery pipeline and tests. And that includes infrastructure as code. And I think I didn't call out earlier, as you move to containers. When you build, you need to rebuild the containers that you're ultimately going to deploy the application in. Go back to the repository, get the latest version of the Docker file, generate that image. If you're modifying your container or underlying infrastructure with infrastructure as code, take that out, build it, run it, deploy the app in it, then test it. Hopefully that answered the question.
That's great. Thank you.
Awesome. So if we can move on to the next. Awesome. And I think this is a perfect time to hand it over to Mitchell. I know, being with DevOps.com, you cover this area a lot, and we've in particular spoken about it, Mitchell. So if you could take us through practice 10, that'd be awesome.
Yeah, I'm happy to. DevOps is such a broad field. There's so many things a part of DevOps, and there's something we were talking last week at the DevOps Enterprise Summit. There isn't one definition. There isn't if you do these 6 things, you are DevOps.
Right.
And while that maybe make it a little bit confusing to kind of get started, what it does is it helps the field, the discipline of DevOps continue to grow and expand. And I think one of the great things about it is, everybody gets a culture at work. It's just, are you intentional about it? There was one that exists and will be created. So there's certainly some things to build around. I mean, of course, the higher up the executive support that you can get, the better. You're also going to need to be prepared, of course, to say, well, why are we doing this? What are the benefits? Where are we spending this money, or why are we changing, et cetera? So you'll need to be prepared to talk in business terms to higher up in the organization. Certainly invest in training, right? We all need help, and also think about training together, things like dojos and et cetera, that help the whole team, and not just development, or not just development and QA, but operations, database, product. Everybody goes through that together, because you know what? No one person or team knows all of it or can figure all of it out together. One of the things I would recommend is sitting down as an organization or as a team and deciding what principles of DevOps that you're going to elevate as those things that are going to be most important to you. There's a lot of things in DevOps. And so some examples would be speed with stability, right? Ultimately, that we're trying to create confidence in the organization that we can very quickly create and deploy software, very quickly respond to opportunities and problems. And that's one of the benefits of doing all of this. Another is high communications, right? We're not hoarding information any longer. We're being transparent, we're sharing, we're communicating, there's metrics, there's all kinds of good things coming out of this. Another is, we're not doing this alone. And that was one of the messages out of DevOps Enterprise Summit last week, is everybody's going through this together, but everybody is also sharing. The more you can share with others, whether it's speaking at a conference, doing an internal talk, talking as a team, how are we going to fix this? Where should we put our efforts around going to the next place? Communicating and collaborating together and being inclusive. So build on that experience of others and help build the practice of kind of building on the shoulders of giants. Another is thinking about redefining everybody's role. This isn't just a difference for ops or a difference for developers or a difference for test. Security people are playing a different role. They're learning how software is being built. Network people, network engineers are part of this process. So don't worry about the titles. We're gonna get rid of titles, or we're going to have soft titles. Lots of things that you could identify with. I think another core tenet is continuous improvement. That's really what is behind driving all this rapid innovation. What kind of metrics you're going to build upon? How can you communicate business metrics? Of course, automation, shift left, fail fast, all kinds of things. And I'm just listing off any number, and you could do a Google search and probably find 25 I didn't mention. But some of those are key things that we are about this, and this is what's going to drive, at least for now, our adoption of DevOps, continuous integration, continuous deploy, et cetera, and evolve that set of kind of key tenets or principles. Guys, anything else you want to add in?
Yeah, well, you know I do, Mitchell.
It was a rhetorical question.
I don't know, Doug, you look like you had a comment before I chime in.
I was just going to say, I broke the build. That's why I'm locked in this closet. That's really not good.
There is some social pressure in breaking the build, isn't there?
Right. That is the one place where you can blame. No, but that's actually a good segue, because I was going to say, why are we talking about DevOps culture now? Well, the reality is, as we saw in an earlier slide, it all builds on each other. And to truly get the throughput and the benefits that we expect to get from DevOps, as we saw with elite performers in the DORA report, and then ultimately software delivery management, culture has to be tended to. Eventually, if you don't tend to it, you're going to run into barriers. One of our tendencies as engineers and technical people is to deal with the hard science and the quantifiable. And CI kind of fits there, right? I create a build, I test it, I add this validation, I have the challenge of how fast and efficient can I make it. But we often fail to tend to the human factor around that makes it work. When we don't do that, I've seen it time and time again, over 3, 6, 12 months, it completely degrades. Then when you decide I have to extend across silos to QA, operations, and ultimately to the business, you're starting at zero. The base culture doesn't work. And the other thing I'd like to share is, I cite this all the time, probably a bit of a fanboy of Chris Bytart, my interview with him on DevOps Radio. But I found it really telling that when we spoke and we talked about technology and tools and the advancement of all the solutions out there, he kept driving back to DevOps is about collaboration. DevOps is about culture. Nobody knows everything. We're supposed to come here and solve this together to find the best solution to make the industry as a whole better. So wanted to add that. Thanks, Mitchell.
You bet. Just if I can just put a point on that, culture really equals people. It's about humans. That's what this is about. If you kind of think culture isn't this abstract thing, it's about us as people and how we're working together. So let that drive what you're going to do. We have a bunch of questions I'd love to get to. So let me start here. Where do we stand with including backouts or disaster recovery as part of this CI/CD process? Really, we talked about kind of fixing things in production. I guess you could wrap into that backing out changes, but also, how do you think about disaster recovery in the CI/CD process?
Well, and I'll hit a couple of things here. One, the first that he probably doesn't mean, right? So, but what's important to think about as you build out your CI/CD pipeline and tool chain, it'll become a critical piece of your development delivery process and a critical piece of your business. So while it may not be the question, you need to provide a production SLA for your CI/CD pipeline and tools. Right? So backup and disaster recovery there. Now, backup and backout and disaster recovery, in my mind, I view as being very different things. But where they do kind of merge here is, if we follow the correct processes, we can regenerate our application at any state from source code at any time. That starts to lead to our ability to have another method of disaster recovery beyond, warm failover, hot failover, a system, on the other side of the country. Now back out, what we're finding is that if you're looking for the ideal, right, we're really trying to implement a process that is mainline trunk development focused, that gives a fast cycle time and iteration time. And so we look to move from a back out or rollback approach to things to a roll forward, right? When we find a problem, if we've properly tested the deployment and everything else, our deployment success rates are high, but we may find issues in production. We want to be in a situation where we can get something ideally out to prod in minutes to fix it so we roll forward. That's not practical for everybody. So oftentimes I talk about, taking a solution like CloudBees Jenkins and CloudBees Core, pairing it with a solution like CloudBees Flow. So you have application release orchestration, which will tend to a model-driven approach to deployments and make it easier to capture your deployed applications and quickly roll them back across complex architectures. So strive for a roll forward approach, but be prepared to have robust orchestration capabilities to support rollback when needed.
I think one of the things you're kind of alluding to also, Brian, is with cloud technology, we can do cascading deploys. It's not all or nothing, which is a great strategy for let's try this in a few markets, few whatever cloud providers.
Yeah,
okay.
blue, green, canary deployments more than our big bang. I guess, I spoke to big bang, right? But
no, it's all part of it. There's a couple questions, and thank you, John, for the prior one. Also, this question's from Pablo asking about database and how do we include database and database development into the CI/CD process. Data has gravity, right? Database has structures. You can't just flip back to the schema from 2 versions ago because you thought it was a little bit better. It's now changing the state and the value of data. How do you incorporate that into the CI/CD process?
Yeah, data is a changing, rapidly evolving, changing landscape, and it's crazy how many aspects of what we do to deliver software are changing. Change is constant, but I feel like and I'll admit, more like 30 years of software development, more is changing and more is changing faster. There's still some work to be done, I think, in I think a robust, repeatable solution for managing at least traditional relational databases in CI/CD. Probably a detailed answer is beyond the scope here, except to say that there are a number of solutions out there, for years, and this is outdated now. Well, that's not outdated. I spoke to somebody last week at DOES that is doing this, and that is they're treating their SQL and DDL as code. They're extracting it, storing it in a repository, and managing and applying it just like they would application code or environment code. And I think I was doing this with customers 10, 15 years ago. Wow, which is hard to say, but there's varying levels of doing it. There's packaged solutions. You can look at Redgate and other similar tools, or there's a lot of roll your own. And just kind of for traditional relational databases, managing your SQL in a similar way as you manage code or infrastructure as code.
Great. Anything to add, Doug? Good on that?
Yeah, I'm good with that. I mean, the problem with changes to schema is if many applications, microservices, et cetera, are using your database, testing becomes really complicated.
Yes.
That's where automation can help a lot too. I just want to give our audience a heads up. We're probably going to go a little bit past, maybe up to 10 minutes past the top of the hour. If you do need to leave us at the top of the hour, remember that we're sending out a link with the recording. You can catch up, listen to the rest of the questions that we have. So thanks for staying with us if you can. Next question is from Ella. How do you automate testing of a new function that was just developed? What's that cadence process look like?
Yeah, to me, that's really.
Go ahead, Doug.
Okay, sorry. To me, that's really a strong argument for test-driven development. Your test case needs to be developed along with your code, whether it's driven by the test case first or not. But you need to make sure that as you're rolling out that new function, you also have testing for it.
Okay, great. Brian, anything to add?
No, just 100%. I know it's a tough transition to make. It was for me personally, but the returns on that are valuable.
I think the more you do it, the more you figure out. It's kind of you get a feel for how to do it too. Let's see. Next question is. again, there's a lot of questions around this database and managing that, but I'm going to jump to this. And if you're using Jenkins, how many nodes can I add to a Jenkins HA? It's kind of a Jenkins specific question, but if you know, I'd love to answer it for.
If you're using Jenkins, how many nodes can I add to Jenkins high availability?
Yeah.
I believe I couldn't fully dig into that. There's a lot of questions that are dependent on what you're running Jenkins on, what your configuration is. So I think it'd be best that I don't even take a stab at that. For this listener here, feel free to follow up with us after the webinar, and we can look to get you a more complete answer.
Great. Next question is coordinating changes to the database with development teams, multiple development teams. Are there any suggestions for integrating those two flows of database changes, development team changes, and how do you decide what synchronization points make sense?
Yeah, let me first, since I would traditionally jump in, defer to Doug on that, because that is exactly what Doug called out as one of the challenges, right? If you have massive databases, shared databases, how do you manage it across applications, which is going to be a standard enterprise case? Any thoughts, Doug?
Right, and to me, one of the greatest sources of inertia in an enterprise is the database schema. Make some changes to that and see what breaks. You will probably meet a lot of new friends, none of whom are happy to see you. That's a vital and frankly fragile piece of an enterprise's infrastructure. So you have to be very careful with that as you're making changes, and make sure your testing is as complete and as automated as possible.
So, and to get into kind of a CloudBees core sort of product specific suggestion for that, and there are multiple solutions, is treat your database and your database schema as a dependent application, i.e. if you manage your database schema changes via CI/CD pipeline, and you have a scalable CI/CD platform like CloudBees Core, what you can do is every time a schema change is made as part of its continuous delivery loop, it can leverage something called event-based triggers to trigger jobs and run some basic tests on all of the dependent applications. And a lot of details we would need to get in there to fully wire it out. But just think about the idea. Your DB team makes a change. Before it deploys to a prod environment, it runs tests as part of its test cycle. It runs a test set for every dependent application against that data. If it breaks, you're not able to go to your production database with those changes.
Mm-hmm. I might throw in too that, again, with microservices, you can help isolate where database specific interface is happening or across multiple sources. API centric or API economy driven applications help with that, and having sustainability of API compatibility across generations of that API help, and a very specific process for identifying when you've deprecated an API that's no longer valid. That can certainly help identify who all is using it, where is this impacted, not just what code's calling this part of the schema where. That makes it a much more complicated problem.
Yes. Yeah.
Okay, let's wrap it up on this question. How do we measure the maturity of the CI/CD practice? How do we know we're like, okay, we are like 1/10 of the way on this journey? Is it the DORA report, or there's some other good kind of metrics, heuristics that we could use?
No, well, you're always on the journey. The CI/CD and DevOps journey is continual.
Brian, go ahead and take that one.
Right. You're always on the journey, hence continuous improvement. But I think there are two metrics. I think sharing industry standard metrics, kind of those leading indicators, as I call them, such as the DORA Fantastic Four, right? That's just, look, if you can deliver fast and not fail, or recover fast when you fail, you're on the right track. And those are actually ideas that you're getting in the place, you're leading towards delivering value. But you also need to implement sort of measurements of your own objectives, right? Part of what I say when you start on a transformation is get all your stakeholders together, identify where you are, where you want to go, and then how you get there. Now, say like Waze. Well, actually, I won't use Waze as an example. I'll just say that where you want to go, from that, you want to extract some key KPIs that indicate whether you're tracking. Are you looking to implement this to increase quality? Are you looking to implement these practices to reduce overtime? Things that may not be in the DORA Fantastic Four, are you looking to improve employee satisfaction, right? Those are all things that you'll have to decide if you're trying to achieve, and then figure out metrics and ways to capture those. And you'll have your own kind of bespoke guide to how close you're tracking to your end objective.
It's a really good point, because there's a cadence, there is a pace at which an organization can adopt certain changes in speed, and always tying it back to why are you doing this? What's the business reason? What's the value you're trying to deliver the business? Is it to deliver functionality, capabilities to market quicker? Is it cut down on the number of production issues or the response time? I mean, there's a lot of different metrics that may be specific to your environment that can help you define. The other thing I would suggest, building on what you said, Brian, is go to conferences, talk to people, go online. That's a great way to informally learn and communicate and say, oh, okay, sometimes you'll realize actually we're not too bad. We're pretty far along, farther than you thought, because it is a journey. There is no one destination or an ultimate that we're reaching, because that's going to change. 2 years from now, we're going to be talking about some new metrics or some new ways of doing this.
Right. A manager I had a number of years ago said, we'll go as far as we can see, and then we'll see a little farther.
Yeah, I love it.
We're not going to get there and say, all right, DevOps is done. No, there's going to be something else to pursue.
No, you probably really said that, right, Doug? You're just making up that manager.
No, that was my manager. I wish I was that clever.
Okay, well, credit to him.
Keep in mind, he's still trying to get out of the closet, Mitchell. So if he said it, he would probably share it. But
I think we'll take a vote after this is over. I'm going to vote for him to get off the island here. So, well, let's wrap it up. Doug, Brian, thank you so much. I mean, you guys are awesome, and the knowledge that you shared, the expertise, because you get so exposed to so many customers, and your experience is super valuable. And none of our knowledge is our own, right? We learn from other people, and I think you both are great examples of learning from so many others. Also, I also want to thank our participants. All the questions were fantastic. I tried to get to most of them. We'll go back and look, and if there's some we didn't catch, we'll catch that offline with you. Just a reminder, we are sending out an email, the link to the recording, the link to the slides. You can also check it out on devops.com and check there too. You have other webinars that are coming up with CloudBees. And don't forget, we're going to email a link to the ebook version of this out in a few days. So thank you for joining us. Join me in thanking Brian Dawson, DevOps evangelist with CloudBees, Doug Tidwell, who's technical marketing director. I'd emphasize the technical. Great job on that, Doug, from CloudBees. And of course, CloudBees, our sponsor today. And I'd like to personally thank all of you, our audience. Well, thank you. I'm happy to be here. I appreciate it, Brian. Thank our audience. This is a lot of time. An hour is a long time to dedicate to a webinar, and we know it's super valuable. The fact that you spent it with us, we are honored, and we hope it was valuable for you. It's been my pleasure hosting today's webinar. Have a great day. Be careful out there.
Bye-bye. Thank you, Doug. Thank you, Mitchell. Thank you, everybody.